Okay, we're going to talk about angles and measuring angles. Now, we have an angle over here. We have angle AOB. Remember, the center letter is always your vertex where the two rays come together. We would say for this problem that ray OA is your initial side. Your initial side is always going to be on the positive x-axis if there was an xy axis listed here. OB would be your terminal side because you would start here and rotate up to get to this one. Once again, O is your vertex. And an angle is in standard position if it's centered at the origin with the terminal or initial side on the positive x-axis. So if I were to draw that in just a second, I'll draw that in. You can see if I put my XY axes in here, that this would be in standard position with the initial side on the positive x-axis. An angle is considered to have a positive measure if you start here and rotate in the counterclockwise position. However, if I started here and rotated all the way around backwards, that would be referred to as a negative angle. So we also have coterminal angles. A coterminal angle is another angle that would be at that same location but goes around more than once to get to it. So if the red was 30 degrees like we have over here, and it went all the way around and then it went 30 degrees, then that would be 390. The blue to go around once would be 360 degrees plus that extra 30 to get back to where we started would be 390. You could go around any number of full time or full revolutions forward or any number of full revolutions backwards. So another coterminal angle would be this, going around a second time and rather than just once. Or if we were at 30 degrees and then went backwards a full revolution, that would be at negative 330 degrees. Or if we went backwards twice, it would be at negative 690. Would not really make a difference. So here we're asked to draw an angle of negative 45 degrees. So we're going to start here, rotate backwards 45 degrees, and we would get this. But besides that, you need to draw and an arc with an arrow on it for your direction, and then put down negative 45 degrees. Here on this one, we need to be at positive 215 degrees. So we'll go ahead and rotate. Here we're at 90. Here we're at 180. We'll be at 215 over here. So then positive is going counterclockwise like we showed you, and then you draw an arc with an arrow and then go 215 degrees. And then we want to do the same type of thing over here. So it's 405, so we got to go all the way around once, which is 350 or 360. Then we'd still have to go more to get to 405. So we'd put it about here because it would be 45 degrees beyond our 360. So to draw that in, we're going to start here, go all the way around once, then come back, and then I would put down 405 degrees. Now, looking here, we have a second way to be able to measure angles, and that's in radians. That's your arc length over your radius. Now, suppose we started out here, went all the way around for my arc length. Well, that would be my circumference, which is 2 pi r. Then I would need to divide that by my radius. Well, my radius would just go from here to here. Whatever size circle I had, it would still be just r. So to go all the way around, My r's would drop. It would be 2 pi. So to go once around in radians is 2 pi, so that's why you see 2 pi listed here. So if I went all the way around, it would be 2 pi. So if I only went halfway around, then it would be pi. If I only went a quarter of the way around, it would be half of that, which would be pi over 2. If I went 3/4 of the way around to get to here, that would be 3 pi over 2. So pi radians is the same as 180 degrees, or 90 degrees is the same as pi over 2, like we were just talking about, or 3 pi over 2 is your 270. Now, you could go ahead and convert between radians and degrees. Now, radians and degrees, we have 180 degrees at the same location as pi. So if we go pi over 180, since they're both representing the same spot, it's really a special form of 1. Or 180 over pi, that's also a special form of 1. We use 180 over pi to convert from degrees to radians. Because if we did that, we would have degrees in the bottom, so we could start out with degrees. Multiplying by this would put degrees in the bottom, causing the degrees to cancel out. We would use this to convert radians to degrees, and we'll do that here. So suppose we have this. If we go ahead and multiply by this, we would now have a fraction times a fraction. You would notice you have degrees in the top, degrees in the bottom, they're going to drop out. What I would do then is I would put 135 in my calculator divided by 180 on my calculator, and then fractionize that, and then just know that you're going to have this pi in your answer. And so then you get 3 pi over 4. We could do that down here, multiply by pi over 180. We know since we're starting out with degrees, we want degrees in the bottom so they cancel. Notice you could cancel also a 0. So I would either simplify 24 over 18 in my head, or put 24 over 18 in my calculator and fractionize it, and just know that I'm going to have a pi in your answer because we didn't do anything with that pi. A lot of times radians will have a pi in their answer. Do they have to? No. But a lot of times they will. Over here, we're trying to end up with degrees, so that means we want to have degrees in the top. And so we're going to have 180 degrees, and I see I forgot my degree symbol. So now we're going to go ahead and simplify this. Pi on top, pi on the bottom. I would go ahead, take 7 divided by 4, multiply it by 180, and then just know I'm going to have degrees hanging out. Same idea here. 180 degrees. And then I would go ahead and cross out my pi's. I'd have 180 divided by 3. You can do that in your head or with your calculator, and that's 60 degrees. We're going to talk about the unit circle in a second video. We're going to do this problem, and then we'll come back. Now, coterminal is angles that end up being at the same location. Now, we did this earlier with degrees. Now, 7 pi over 3 is going all the way around once and then going up to here. So just past that. Now, in reality, this should be a little bit farther up. It should be to there, and if we draw it correctly. So this is 7 pi over 3. So coterminal, when you're dealing with radians, is still adding or subtracting a full revolution. Well, remember in radians, a full revolution is 2 pi. So we'd have to take our 7 pi over 3 and either add or subtract full revolutions. So if we did go ahead and just subtract a full revolution, we would get this, because this, if you do a common denominator, would be 6 pi over 3. You'd be subtracting 7 pi over 3 plus or minus 6 pi over 3 would be this. Or if you subtracted another 2 pi, which would be subtracting another 6 pi over 3, would be negative pi over 3. And negative 5 pi over 3, sorry. Or you could have added another full revolution, and you'd have 7 pi over 3 plus a full revolution of 6 pi over 3, and you get this. So now we'll go back and deal with the unit circle, and that'll be in a second video.